So when we talked about domains of predicates at the very beginning of our predicate logics, we talked about sets, and also we talked about relations and databases. So let's revisit that topic a little bit and talk about some special kind of relations and their properties. So just to remind you, the sets were, the relations were sets of pairs or triples or n-tuples of elements from not necessarily the same sets. And some of the running examples of relations were the less than relation, the likes relation, person X likes person Y, and a parent relation, person X is a parent of a person Y. We also had some more complicated relation in the context of databases. So another way of saying what a relation is with the language of Cartesian product that we have now is a relation is a subset of a Cartesian products of some sets. So if you take two sets and take their Cartesian products, you end up with a set of pairs. And a subset of that set of pairs is a relation. For example, if A is 1, 2, 3 and B is AB, the same two sets that we used in the definition of Cartesian products, then we have 6 possible pairs. So Cartesian products of A and B consist of 6 pairs, each pair of 2 elements. And now we could take, for example, a relation that only has pairs 1A, 2B, 3A, and 3B. That's a relation. Well, so is A Cartesian product B. That's a relation that just everything. If you take a relation that's an empty set, that's fine. If you take a relation that contains only one pair, for example, 1B, it's also a relation. So one way of drawing relations is similar to how we were drawing functions. And this is what we would use when this relation is a product of two different sets. We would say on the left side we will have 1, 2, and 3. On the right side we will have A, B. And we will say that a relation R relates 1 to A, but only to A. It relates 2 to B. And it relates 3 to both A and B. Notice that if 3 were related to only one of them, this would be a special kind of relation called a function. If a relation is a subset of a set which is a product of a set with itself, then there are other ways of drawing it, and there are all sorts of things that we could say about this relation. So in particular, you will see a lot of drawings or a lot of things later on in your later courses that are drawn as graphs. So what is a graph? Graph is a visualization of a binary relation which is a product of a certain set with itself. And that's a diagram that has a point for every element of your set A and has an arrow, a connection between 2 points if the first point is related to the second one. So for example, if your set is 1, 2, 3, then you could have a relation which relates 1 to 2, 3 to 1, and 1 to itself, and 2 to itself. So one point of confusion is that you probably saw the word graph meaning something very, very different looking. You were talking about a graph of a function. You were plotting a graph of a log function or a square function. What is the relation between relations, graphs of relations, and those ones? Well, in a way, they're just visualization, graph meaning visualization, but of kind of different things. For the relations, you're really thinking about a point on a plane as your x value point followed by the y value. And then you draw it on a plane like x followed by y, and then you make a line. But here, we want to be talking about things in slightly different way. We want to be talking about is point x related to itself or not related to itself? Is every point that's related to some other point has that other point relating back to it? And that is much easier to do with the kind of graphs we draw here, where we have a separate point for every element of A, not for every pair of elements. So if this gets confusing, just think about the graph here as being a completely different beast from the graphs that you saw before, the graph of square function or a log function. And the kinds of graphs that we are drawing here, you're going to see a lot, especially when you are doing algorithm and data structures, because surprisingly, a huge number of computer science problems can be represented as graphs. And there is a huge number of algorithms that you are going to study later develop for those problems. If you think about a network, well, a network is a graph. If you think about artificial intelligence, a neural network is a graph. It's a slightly more complicated kind of graph, but a graph nonetheless.